Hello everyone. In this video, we will understand recursive functions. First one, to determine the GCD and LCM of two numbers. And the second one is binary to decimal conversion. We can see how compactly we can write the program using recursion. So the first one is to compute the GCD and LCM of two numbers. We'll just have a look at it. We'll take the two numbers as 8 and 6, that is num1 as 8 and num2 as 6. And we know that the GCD of 8 and 6 is 2 and LCM of 8 and 6 is 24. We'll write the function for the same. So find GCD to determine the GCD and find LCM to find the LCM, and both of these take the parameters num1 and num2. So in the main, we'll read the two numbers from the user. Into num1 and num2. Call the function find GCD to determine the GCD of two numbers and print it. Now this is just to pass the largest among num1 and num2 for our LCM function. So we are doing this. If num1 is greater than num2, call the function as num1 comma num2. Otherwise, you pass num2 as the first parameter and num1 as a second parameter. Okay, and display the LCM of the two numbers. Now coming to the function, we'll just trace this with these numbers. So our n1 is equal to 8 and n2 is equal to 6. This is basically called as Euclidean method of determining the GCD of two numbers. The other approach is using factors, right? So while n1 is not equal to n2, the condition is true. Now if n1 is greater than n2, again 8 is greater than 6, we have a recursive call. We already know that a recursion is basically calling the same function with different arguments. So I will have here 2 n1 minus n2 comma n2. Now this will be pushed onto the stack because there is again a call now. n1 minus n2 now becomes your n1. So this will be 2 and this will be as it is. Now again the condition is true. n1 is not equal to n2, 2 is not equal to 6. If n1 is greater than n2, 2 is not greater than 6. So this statement will be executed. So I will have find GCD n1 is 2, n2 minus n1 6 minus 2 is 4. Again this will be pushed onto the stack. Now our new value for n2 is 4. The condition is still true. n1 is not equal to n2. n1 is greater than n2. This is also false. This is false now. So I will execute this statement. Find GCD with different arguments. n1 is same. n2 minus n1 is 2. Now check the condition. So our n2 is 2 now. 2 and 2. n1 is not equal to n2. This condition becomes false. You come out of this while loop. Return n1. So what is our n1? n1 is 2. Now the back tracing happens. So for this function, the return value is 2. This will be substituted here, 2. This will be substituted here, 2. Finally, for this last call, you will have return n1. So this function with 8 and 6 as the parameters will return the value 2, which will be printed as the result. Now coming to LCM on the same parameters 8 and 6. Here a variable called temp is declared as static. Since these are recursive calls, that is, you will be calling the function again and again, okay, We do not want this variable value to change in every call. So I declare it as static. Okay. So now this variable will keep on incrementing until we find a value which is a common multiple for both 8 and 6. Just have a look at it. So 1, this condition, 1 mod n2, 1 mod n2 or n1, n2 is equal to 0 and okay, 1 mod n1 is equal to 0. If this is true, then you will return temp. Otherwise, increment the temp by 1, so our temp becomes 2. You again call the function n1 and n2. Okay, so again you will perform 2 mod 6 and 2 mod 8. If both results to 0, you return temp. Otherwise, you recall the function, you increment it and recall the function with n1 and n2. So this is also not true. This goes on until temp reaches 24. 24 mod 6 is equal to 0 and 24 mod 8 is equal to 0. So in that case, you will return temp. Right? So this will be returned here. This will be returned here, and you will print the result. The next recursive program is on finding the decimal equivalent of a binary number. So for example, if I take the binary number as 101, the equivalent decimal value is 5. Let us have a look at the recursive calls or recursive function to design this program. So let us declare few variables, the decimal number as 0, binary number, and weight as 0. This weight basically indicates how much you have to raise it. For example, now to convert, how do I convert this? 1 into 2 to the power of 0 plus 0 into 2 to the power of 1 plus 1 into 2 to the power of 2. So these are nothing but the weights. 2, 1 and 0 are the weights. Okay, so ask the user to enter a binary number. Call the function binary to decimal by passing the binary number. So in this case, I am passing 101, decimal number is 0 and weight is also 0. We'll just have a look at it. So our binary num variable, it has the value 101, decimal num has the value of 0 and weight, okay, here in this case it is bit, this has the value 0. So binum, decimal num and the bit. Right? If binum is greater than 0, 101 is greater than 0 condition is true, start peeling the number one by one. So what happens in this case? 101 mod 10 will give me 1. So decimal number is equal to decimal num, initial value is 0. So this becomes 0 plus binary weight, that is 1 into power of 2 comma bit 0. So this will give me the result as 1, right, which will be stored in our decimal number 1. Reduce the number, binum divided by 10. So 101 divided by 10 will give me the answer as 10. Bit plus plus. Okay, so bit now becomes 1. Right, so binum is 10. Let us look for the second iteration. Now here I am recalling the function with different values. So what is our binum now? It is 10. Decnum or decimal number is 1. What is bit? Bit is 1. Now check the condition. Binum is greater than 0. Condition is true. Weight is equal to binum divided mod 10. So this becomes 0. Decnum is equal to decnum plus this. So this becomes 1 plus 0 into power of 2 comma 1. So this results into 1. So this again results to 1. Now reduce the number. So this becomes 1. Bit plus plus. So this becomes 2. Call the same function again with binum as 1. This as 1 and bit as 2. This is our call again. Now check. 1 is greater than 0. Condition is true. Now in the third iteration, this becomes 1, right? Then decnum is equal to 1 plus 1 into power of 2 comma 2. So 2 comma 2, this will result to 4. 4 into 1 is 1 plus 1. This will result to 5. So this is 5. This becomes 0. Bit plus plus, this becomes 3. You call the function, you recursively call the function, okay, with different values. Okay, so you will have 0 here. This is 5. This is 3. Now on this condition, this becomes false. Binum is greater than 0. This becomes false. And you come out and return this decimal number. You return this decimal number, which is stored here, and you print the decimal number and the binary number. So in this case, 5101 is printed. Thank you for watching.